group calls themselves the Fantastic Four.
Go Braxton! Go Braxton! Go Austin! Go Braxton! Go Braxton! Austin!
Tim, let's sit bar at your table for a minute.
Austin! Keona.
Ladies and gentlemen, I would like to present the teams 1, 2, 3, and 4. Today we will be talking about transportation, water, electricity, and housing. Team 1 is up first, so let's give it up for Braxton.
And I was the team leader of Group 1. We were in charge of making a house that could keep heat in and keep cold out. We need this house for a place to survive and a place to keep safe from severe weather. And I made it heavy on purpose so it wouldn't blow over in heavy winds and severe weather. Days 1 through 3, we took notes and figured out what materials we needed. We found what would work for insulation, which was newspaper, and we started to talk about who would make the PowerPoint and who would make the building. Days 4 through 7, we started to build our house with the outside being rubber, the insulation being newspaper, the windows being plastic bags, and the doors being aluminum cans. Days 8 through 10, we started to build using the materials we needed, and we cut out the rubber, the newspaper, and the plastic bags. Step 1, we needed to find a cardboard box that was a rectangle, which we did. Step 2, we cut out the door and windows and put aluminum cans for the door. Step 3, we cut out the newspaper to fit all the sides of the box, which we did for all the sides. Then we cut out pieces of rubber for every single side. First for the building, I put the newspaper on the sides for the roof and the walls. And then I did the same with the rubber. Next, we placed the rubber onto the newspaper and glued it on there. Our biggest issues was finding the materials we needed to build it. Our main problem was finding something strong enough to hold the rubber onto the box. Another issue was time. I was usually busy with baseball on the weekends. And now for team 2.
In my group we had Holly, Asia, me, and Eric. We were in charge of purifying the water. We used the idea of distillation to purify the water. For those of you who do not know what distillation is, it is the heating of water to clean it. Our biggest issue was what we could use that was recyclable, and we couldn't find anything, but we ended up finding that aluminum was still around. So we used that as our main part. We used the flower pot to help hold on the cover when it was boiling, because the cover would not stay on while it was boiling. We had to let the water cool because hot water does not taste good. So for the materials we used a rubber tubing, flower pot to hold on the cover, a cup to put in the clean water, and a aluminum pot to hold in dirty water.
The Battle Elixir by Mackenzie, TJ, Keona, and Christian. Wind power. Estimates show that by 2050, 25 to 30% of all electricity will come from wind-related sources. Most of that will come from wind turbines. It works the opposite of a fan because instead of forming wind, it generates it to make electricity. Wind turbines take the kinetic energy from wind and turn that into mechanical power. That mechanical power can be used for specific tasks, such as grinding grain or pumping water. Wind is a type of solar energy that uses the Earth's uneven heating by the sun, the Earth's surface, and the rotation of the Earth. The two classes of windmills. The horizontal axis and the vertical axis are the two classes of windmills. The vertical axis design was popular in the early development of windmills. However, its inefficiency of operation led to the development of numerous horizontal axis versions. There's a variety of these, including the tower mill, smock mill, post mill, and fan mill. The materials and how we made the Battle Elixir. The materials we used were a marker, cardboard box and scraps, a copper wire, a wooden paintbrush, and hot glue and tape. How it was made, Keona and her father took one of her markers and drew what looked to be a big cross of it. After that, they started to find a cardboard and some scraps. They measured it all up and then began to look for a small box, cutting off the sides so the wind turbine panels could move easier. After they had done that, she took one of her older brother's guitar strings, which was made of copper, and wrapped it around the wind paintbrush they used so the wind turbine had something to rotate on. And with a magnet and a little wind, they were done. And Keona, could you please explain to the audience how the invention works?
This one, Eric. What? Go back. Video. Okay, so I have to explain this fast because I didn't want to take too much of a video. So as you see here, the wind is shifting the the cardboard windmill here. And as the wind moves it, as you can see, the copper is right down there, and beside it are two magnets. Now when it spins, the copper goes through the magnetic field, twisting it, cutting the when it cuts the magnetic field, it generates electricity. And if we had a generator, it would store that electricity and push it towards other things like charging your iPhone, maybe starting your car, or maybe having a refrigerator that just works. And that is what we did for our windmill. The Coca-Cola Express. Now, we had a problem. We had no cows, no pigs, no chicken, so basically no McDonald's whatsoever, folks. Wooden boats, well, those don't last that long. I'm not a fisherman or anything, but I just know that when we use the wood now for other materials, as you can see here. So that was not the solution here. So we had to use recyclable materials as it was given to us by our teacher, Miss Manno. So we decided, let's use plastic. It was easy, reliable, and we had a lot of it. So now, this is what I was looking at when I was thinking of how we do the plastic bottles. And I was thinking, that is a lot of plastic bottles, folks. I mean, that would just take so much hot glue and so much. But some people like it like that, so we decided to do it another way. So now, this is a lot, but my dad also helped me again, like that, with cutting this so we didn't get hurt here. So we had cut off at least less than half of the top so we could fit my iPhone case inside there, which preferably an iPhone 6s Plus. And then when we did that, we had it fit inside there, and the tough part about it was that we couldn't exactly figure out how to let it stay there, because of course, with any pollution, with any troubleshooting, this was no problem. But then when we figured it out, it was all good to how to get there. We stuck it inside there and put some more materials inside it to make it heavier so that it would stay and have some weight and the balance out, because if it didn't, it would just pop out of the water and people could get hurt. So we decided to do that by cutting off the hole also to make sure that all the air stays in there and make a little bit of a ladder. It may not work now, by the way, but in the future, I'm sure there are some wooden ladders we can pull up and to get on this boat. We would like to see the video. Yes, it does float. We tried it in dishwasher, also a different type of water. And the question is, why is the water colored? It's because of the paint used on it, which probably shouldn't use watercolor on a water-based book. Still, it does work for all. It does work for everyone. I mean, maybe not stuffed bears, but you get the idea, folks. And there it is, the Coca-Cola Express. Thank you.
Our next group is called the Lifesavers.
Not today.